What if I told you that the reason anything on Earth moves, from the wind and the tides to the blood in your veins, is all thanks to one massive planet-sized engine? Well, today we're diving into a really wild theory of physics that says just that. And it gets better. It suggests that this very same engine could be the key to unlocking travel to the stars. So let me start with a weirdly specific question. Can you think of any liquids here on Earth that don't have water molecules in them? Now, your first thought is probably, yeah, of course, things like liquid mercury or pure alcohol. But according to the source material for this explainer, that's really only half the picture. The theory we're looking at says that even if water isn't in those liquids, its presence on our planet is the fundamental reason anything here can flow at all. You see, the core idea here is that hydrogen and oxygen are so much more than just common atoms. The theory proposes that together, they act like a giant planetary-scale muscle, providing the raw power for every single fluid and gas on Earth to move. Think about how your own muscles work, right? You've got these tiny proteins that grab and pull on each other to create a contraction. Well, this theory suggests that hydrogen and oxygen are doing the exact same thing, but on a molecular level. Their natural polarity, that sort of magnetic tug of war, is the active force that literally pulls on other, heavier molecules, giving them the kick they need to overcome inertia and start flowing. Okay, so if hydrogen and oxygen are the muscle, the engine doing all the heavy lifting, what keeps the whole system from just overheating? That's where nitrogen comes in. It makes up about 78% of our atmosphere, and the theory says it's not just sitting there. It acts as this massive, passive heat sink. It's the cooling system for our planetary engine, soaking up all the excess energy so the HO muscle doesn't go into overdrive and burn everything out. So if this HO engine is what makes things go here on Earth, what happens when we leave? What happens when we go to space? Well, the theory says our planetary system isn't some special one-off. Nope, it's just a really high-pressure, dense version of a system that's all over the universe. The problem with space isn't that it's empty, it's that the fluid of space is just incredibly thin. There's nothing to push off of. And that brings us to the proposed solution, something called the ionic clutch. Now get this. Instead of blasting mass out the back like a typical rocket, a ship would generate a special reactive field all around its hull. This field would effectively grip the sparse hydrogen atoms that are floating around in the vacuum. It would allow the ship to literally pull itself through space. It's like you're taking a little piece of Earth's engine with you. But that clutch is only half the system. The other half is the engine itself, an engine designed not to fight the vacuum, but to use it as fuel. And this is where we get to the heart of it all, a concept called space-only cold fusion. The proposed cycle here is, well, it's pretty fascinating. Let's walk through it. First up, ingestion. The ship sends out a signal that's tuned to pull in hydrogen fragments from the vacuum. Then the handshake. These fragments are guided into that reactive field we just talked about. Step 3, and this is the absolute key. A theoretical device they call a radioactive cutter emits a super precise counterfrequency. The goal? To completely cancel out the electromagnetic force that normally pushes protons apart. And with that barrier gone, the final step is fusion. The atoms just fall into each other, releasing all their binding energy as pure radiative force. That's your propulsion. But wait, how could this possibly happen without the insane heat and pressure of a star? The theory calls it a magnetic domino effect. The idea is that in the quiet, low-energy environment of deep space, all it takes is one perfectly tuned signal to flip the magnetic orientation of a single hydrogen atom. That one flip could trigger a chain reaction in the atoms right next to it, getting them all to line up perfectly, creating the opportunity for them to bond, all without needing the brute force of a star. Now, I know what you're probably thinking. This all sounds absolutely incredible. Maybe a little too incredible? So we have to do our due diligence. Let's play devil's advocate for a minute and look at the very real, very hard walls of established physics that a theory like this seems to fly right in the face of. And this table really lays out just how different the thinking is. Standard physics, right? You carry your fuel in big tanks, you shoot it out the back for thrust, and you use a reactor for energy. This theory says no, you collect your fuel from the vacuum, you couple with it for thrust, and you use a radioactive cutter to trigger a bonding event for energy. It's a complete 180-degree paradigm shift. And that shift runs into some major hurdles. First, there's ram drag. Scooping up matter when you're moving at high speed should act like a brake, not an engine. Second, you've got the Coulomb barrier. The natural repulsion between protons is just incredibly strong, and overcoming it takes a staggering amount of energy. And third, the energy gap. So far, every fusion experiment we've ever run on Earth has shown that it takes way, way more energy to even start the reaction than you could ever hope to get back out of it. So that's it, right? Case closed. 3 huge, seemingly insurmountable problems. Well, the theory's response to all this is actually pretty simple, and it completely reframes the entire debate. And there you have it, that one question. The core argument is that our entire frame of reference is the problem. Every single one of those hard walls of physics, they're all based on data and experiments that were conducted right here on Earth. According to this theory, Earth is pretty much the worst possible laboratory for this kind of physics. Our thick atmosphere, our powerful magnetic field, all of it creates this constant, high-frequency static, this noise. Trying to achieve the delicate quantum resonance needed to trigger this kind of fusion here is, and I love this analogy, it's like trying to ring a bell underwater. The signal just gets completely muffled before it can do its job. And this comparison really drives the point home. Down here, in an Earth lab, the signal gets drowned out by all that noise. So much energy is wasted just fighting against friction and our environment. That's why success here has always required brute force. More heat, more pressure. But out there, in a space lab, the signal is pure. It can resonate. Energy transfer is incredibly efficient. So, according to this theory, success in space doesn't require force at all. It just requires precision. And that energy gap we talked about, it disappears because you're no longer fighting the planet itself. Which leaves us with a really fascinating final thought. Look, this theory could be right or it could be completely wrong, but it forces us to ask a really important question. What other fundamental truths about how the universe works might be completely invisible to us, simply because we've never tried to look for them from outside the constant noise of our own world? What discoveries are just waiting out there for us in the silence of space?